Welcome back. Welcome now to our last panel of the Aero Days 2020 forum. And the title of this last panel, well, brings us a more than interesting headline, Visions of Future Aviation. This sounds pretty thrilling. Does the future of aviation lie in a little bit more fuel reducing here or a little bit more aerodynamic improvement there? Well, we all know that everything will be important. But yesterday, here in Berlin on a panel, a panelist asked, where's the Tesla in aviation? Where is the disruptive technology? And not only in the labs, but in everyday commercial operations. So I'm very much looking forward now to follow our panel into the future of aviation, and it's a pleasure to introduce the panelists to you. My welcome goes to the chairman of the Association of European Research Establishments in Aeronautics, to Michel Peters. Welcome from the University of Delft, senior lecturer Joris Melkert. Tom Enders called him the father of electric flying. Welcome to the CEO and CTO of VoltAero, Monsieur Jean Botti. From IMI, the Institute for Infrastructure, Environment and Innovation, the director Frank Neumann. It's good to have you here with us. The CEO of Flying Whales, what a wonderful company name, Sébastien Bougon, welcome. Welcome to Daniel Doulton from Sceye. He's live with us in San Francisco. Daniel, I think it's 3:30 in the night in San Francisco, so what a contribution to this Congress is this. Thank you. I hope you have a strong coffee nearby. And welcome to Andreas Hardeman from Boom Supersonic. It's good to have you here. And your session chair is nobody less than the advisor, Future Air Transport at European Commission, Sebastiano Fumero. We are all ears. You have control.
Thank you very much. Thank you very much indeed. If it's true, if someone is looking for a Tesla in aviation, you should listen carefully to this panel. This is the last, but not the least panel, for importance certainly. We have been listening and having a very interesting panel till now. But now I would like to guide you through a journey on a possibly different aviation paradigm. The main driver of this session will be the following question. Will the sky and the flying object be the same on a near or far future? My panelists are all working on an extremely interesting project. And I firmly believe that, yes, we are going to be amazingly surprised. And that soon we will look at the sky. If we are looking at the sky, we will see many and different unconventional type of aircraft. I'm quite excited about it. So let's start now the journey. Let me introduce our first panelist. Is my friend Michel Peters from the NLR. That is not only representing the Royal Dutch Aviation Research Center, but is also the current chair of the EREA, the European Research Center Association. Welcome, Michael. So the future is tomorrow. According to your large experience and vast knowledge, how the sky will look like in the near future? The floor is yours.
Well, thank you, Sebastiano. I've prepared a couple of slides to illustrate that. And thank you to the organization for inviting me to be part of this panel. Really pleasure and honor to be here. And as you know, and as Sebastiano told you, in normal life, I'm the General Director of the Royal NLR, but I've, in this case, the honor of representing EREA here today, the European Association for Research Establishment in Aviation. So on the next slide, being in aviation research and innovation, talking about the future of aviation is easy. We see the future every day. In a way, the future is our core business. That's why EREA decided to put that in writing. A couple of months ago, we started work on a vision document that consists of two parts. The study first looks into possible scenarios of how the future might develop. And after this, we determine what it takes to make these future scenarios a reality. Today, together, these documents form the EREA vision on the future of aviation. On the next slide, I'm happy to share with you these 4 scenarios of the future. And you all understand it's not a black and white discussion. It is not exact business. There are 4 possible scenarios and all the variations in between. But many of you will already have seen it yesterday in our dedicated session. Key factors in each of these scenarios is the extent to which we work together in Europe and globally, the role of governments, and to which extent research and development is employed to evolve or revolutionize aviation and the transport system as a whole. The question is, will deglobalization and fragmentation set in, fueled by nationalism and populism? Protectionism and economic instability will likely then limit R&D efforts and the focus on sustainability. Aviation will be a luxury, but of course, there is an opposite scenario where harmonization and globalization continue to bring people and countries together and behind a common goal and purpose, an environment in which technological progress thrives and sustainability mobility is considered a right. I will not go into the scenarios in detail now, but the illustrations here say it all, I think. On the next slide, yes, it's on. You can see what's common in all those scenarios is that no matter what happens, we will move towards a more comprehensive transport system. We also expect an increased public awareness and demand for security and safety of this system, including health threats, demanding R&D to step up its game. Aviation will become more and more expensive, albeit the different scenarios provide divergent motives for this price increase. A broader technological development and incidents like a pandemic will accelerate the availability of alternatives to travel. However, at the same time, we expect new modes of mobility to emerge and mature, such as UAM, of course, flanked by digitalization wave. On the next slide, at the same time, we also see some trends that do not occur in all scenarios. Take, for instance, the focus on sustainability. And in some scenarios, sustainability is largely neglected as demand has dropped. Economic instability redirects focus towards primary necessities of life, or alternatives to travel have emerged. In other scenarios, it's at the center of aviation, either strongly enforced at the government level by limited standardized options for the consumer or significant societal awareness and or pressure. R&D follows a similar pattern and is surprisingly aligned with the focus on sustainability. It seems that the drive for a clean planet is directly correlated to the realization that R&D plays a key role. When sustainability is embraced fully at every level of the society, R&D efforts flourish and support advancement in sustainable travel. When sustainability is neglected, the role of R&D is also more limited. These points are a clear direction that in order to achieve climate neutrality, we have a healthy research and innovation ecosystem and to realize a sustainable future for aviation. The degree to which we are all rally behind a common goal is absolutely essential. Cooperation with and between governments, society, industry, research, education, just to name a few, only with open cooperation and the EREA vision for the future can come true. We are now in the process of finishing first part of our study, and the second part is well underway. I'm excited to share with you the whole study somewhere in the first quarter of next year. As a final remark, I would like to stress the need for proper public and private funding. I do not have to tell you anyhow how fundamental and severe this crisis is on aviation is going through at the moment. And as a consequence, private investments in R&D are just not scaled back or scrapped altogether. They are also directed towards less risky investments. Public investments must step into that void, not only by increasing investments, but also by de-risking investments. I'm very positive about that we can achieve that climate neutrality goal in the future with the help of the complete innovation chain. So not only with the expertise of EREA, but also with the expertise of the industry and the universities. Thank you very much.
Thank you very much, Michel. Very interesting. As a representative of the institution, I will have to say that the message is well received. I have a question, Miss, just quickly before giving the floor to Joris. You were saying that in the 4 scenarios, the aviation will be more expensive in future. According to you, there is a way to keep the cost of flying affordable. So it means keeping a democratic way of flying in the future.
Yeah, I try to answer, Sebastiano, but the audio is a bit bad. You talked about the cost of aviation. It was not quite clear to me. Could you please shortly repeat it?
Yeah, you said that the aviation cost for passenger will be more expensive in future. Can we do something different in order to keep the aviation still democratic?
Yes, well, more expenses perhaps in the transient period. If you want to go to climate neutrality, emission-free flight, of course, then you have to make large investments in R&D, of course. Because yes, we want climate neutrality, but also yes, I think aviation must still be one of the most safest means of transportation. So, and that's why I made a plea that also investments from the governments are essential to keep it at a reasonable pace.
Thank you very much, Michel. I will come back to you with some other question later. Let's go now to see, to have the vision of the academia. Allow me to introduce Joris Melkert from the University of Delft. Joris, please present to us what is going to happen according to your knowledge and investigation.
Okay, thank you very much, Sebastiano. Yeah, what I'm going to do in this 5-minute pitch is to tell you what do we need to do to reach climate neutral aviation, because that is going to be our license to operate in the future. If we do not manage to get that going, we are in serious trouble. So for that, I made an inventory, and I will close with a message. So first, in the inventory, what you see is that there is an unbelievable amount of new designs, and I have some on the coming slides. But the question is, will they be able to deliver a significant contribution to make aviation climate neutral? So let's take a look. So let's go to the overview. I just took a snapshot of what is available in new developments, and it is really mind-boggling for an aviation engineer. This is fantastic what is going on here. However, there are so many of them, so we need to group them and to see what their contribution is going to be. So the first group we have is the what we call urban air mobility and general aviation. We see enormous amount of developments here. They are unfortunately not the large contributors to the climate impact of aviation, but these are the ones that we could make electric and make climate neutral right from the beginning. So there's quite some opportunity here. Next group I would classify as the pure fantasy aircraft. You see every now and then a couple of these designs. I would say forget about these. Those are absolutely not realistic, but it's nice to look at. Then we go to another group, which is supersonic aircraft. And you see a lot of development, and we'll hear about that later as well. I expect that is not going to be the transport for the masses. And it's probably also going to be a very difficult one to make climate neutral, but we will see a development in supersonic aircraft coming. And then to the next slide, these are the significant contributors, the large passenger aircraft, and we can expect that very soon we will see these type of aircraft coming. Large wingspans, very efficient wings. A bit later, we probably see the more fancy designs, the flying V, blended wing body designs, frontal planes. But this is not going to be easy. Where did I hear this before? Well, President Kennedy said that when he introduced the mission to go to the moon. He said, we choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. So my suggestion is today to change this a little bit. I think we should say we choose to make aviation climate neutral. We choose to make it climate neutral in this decade because we do not have more time to make it climate neutral, because investing in aircraft, introducing aircraft in the fleet will take more than a decade. So we need to make it climate neutral within 1 decade. I think that should be our challenge. So here comes the message. If we are really serious about this, we need to be aware of a couple of things. First thing we need to be aware of is that we have to develop science, engineering, and technical capabilities never achieved before in history. And this will require an investment of a yet unknown, but significantly amount of money, a large amount of money in research and development. And we have to do this with qualified people. And we have them, we can train them in our own universities. But at the moment, we don't taking the big steps. We only take baby steps. So we need to dream a bit further. Our dreams are now too small, and we're not investing enough to make our large dream reality. And I challenge you to make large dreams reality. Thank you very much. That's the pitch I want to give you today.
Thank you very much, Joris. Thanks also for having respected the timetable. Very good. Means, of course, this is what you are suggesting is what we are thinking in the institution. And this is why, for example, that we have requested the aviation stakeholders for the future clean aviation to look at the more disruptive technologies in order to be able to reach in the time frame that we have indicated the objectives of having a different aviation, a different kind of aircraft, a different kind of a much greener aviation. So let's go on, and I would now to go to Mr. Jean Botti from VoltAero. His company is working on a full electric aircraft, and I'm particularly interested in this concept that he can give a different way of looking at the connection in a much greener way. Mr. Botti, the floor is yours.
Yes, so I don't know if you can see my the first slide. Yes, I need to move up a little bit. Okay, good, because I need to be able to my slides. Okay, so I'm glad that Joris showed the picture of VoltAero just before. You see the plane here, and he said something that is correct. I mean, we in general aviation, and that's our target, general aviation, we have less impact than the big aviation, but in this kind of technologies you have to take baby steps before you can run, and this is the third airplane that with my team we're making, the third electric one. This one has is basically I would say our goal is on 3 words. Okay, number 1, it's hybrid electric. Why? Because we want to make something that is a combination of electric motors, internal combustion engine, but here the electric, I would say, motors are the key propulsion, and the thermal engine is just there for recharging the batteries and also provide safety. I think it's important to say that this additional feature of having 2 sources of energy on board provide the redundancy to make general aviation a lot safer overall. And I think that's something we cannot discard. And then you get the range also, which is missing in most of the I would say pure electric aircrafts. Modular. VoltAero is a family that will be available in 4, 6, and 10 seats, used not only for commercial aircrafts point to point, for regional travel, but also in air taxi and for utility category missions like cargo, post-delivery, medevac, and also for private owners. Our objective here is to have a scalable airplane that's got multiple usages, and doing this using infrastructure that is already existing. That's very important, okay? We're not trying to create new stuff here. We use better what is already existing. Then we're basing this on experience. In our team, VoltAero, I was before a CTO of Airbus, and the team has continued to work to create VoltAero. It's the third airplane that we built. We started with the Cree that was a 20 kilowatt, and in 2011 we went to do this flight across the English Channel in 2015 with EFAN, and that was 60 kilowatts. And today, what I'm showing you here, and you'll see the demonstrator that flies on the 10 seats configuration, we're at 600 kilowatts. So in 13 years, okay, we went from revolution through evolution, but we have multiplied basically, by 30 the power on board. Next slide. Sorry. So on the three priorities we have, we promote regional transportation. We want this to be innovative, sustainable, and competitive. Okay. For a cleaner, I would say, aviation. And specifically, we want to it's a different aviation, it's more scalable, and specific in the area of COVID-19, like we have seen, I think there is a way to develop, better our infrastructures. Today, a lot of small airports are suffering to be underutilized. I think we need to create a different demand, okay? Then we need to develop hello? Can you hear me? Yeah. Then we need to develop an e-aviation ecosystem, and this has to be done with multiple partners. And we have one right now we have developed. And finally, ensure European position in e-aviation. And that's, I think we have many technologies in Europe and many good companies in Europe to develop this e-aviation. In particular, we're very proud to have received from the EU, let me go to the next slide here. Sorry, can you see the slide? I don't see the slide moving. Sorry, the slides are not. Can the operator go to the slide that is the one on Seal of Excellence for Europe? Can you move it for me, please? I would like to see the Seal of Excellence there. It's the, hello? I would like to move to slide 4, please. I cannot move it myself. The Seal of Excellence, EU Seal of Excellence, please. But in any case, I'm going to continue. We have just received the Seal of Excellence from the EU and the fundings. And the jury said at this stage, it is a real innovation due to the cycle of the sector, and it has the potential to impact the market. I think that's important. The airplane by itself is one thing, but it has to be in an ecosystem that guarantees, a sustainable business at the end. And I think this, the team, it says, is extremely knowledgeable and experienced establishing this in the aviation industry. So the Casio family of aircrafts, it's this new slide, exactly. Thank you. This slide, we have three versions, 330, 480, 600, 4 seats, 6 seats, and 10 seats. And now, I would like, because of time, I would like you to play the movie of the demonstrator that we have been flying on the 10 seats configuration. Please play that movie. Can you play that movie, please? I don't see the movie. Okay, thank you. This is the 10 seats configuration, 600 horsepower, kilowatts, excuse me, 800 horsepower.
Okay, thank you very much. Yeah. Thank you very much, Jean. Very interesting. I apologize. We have experienced some technical problem. I hope that our technical support will solve it quickly. In the meantime, I would like to ask you a couple of questions. I was particularly impressed by your presentation and particularly interested in this new way of making regional transportation. That is particularly interesting, especially for regions that they are not well connected. And another element that I catch in your presentation is to make a better use of this existing facilities and infrastructure. That is also an important element of any business plan, because it's not demanding to invest on the infrastructure in order to make it operational. And I would like to ask, when you envisage to have to start your operation not in a pilot phase, but as an offer?
We're planning to be in production with the Casio 330 at the end of 2022. We have already partnered with infrastructure people, airports, and also with a US company that is going to develop the optimal usage of aircraft, dependent of the position, and it's like a Uber of the air. So we're trying to create this triumvirate that will help, to develop this regional aviation.
Okay, thank you very much. I will maybe come back with other questions later on. Now, if Frank is online, I'm seeing him. Yes, Frank Neumann, and him and the two following panelists will present us something very new. I hear a lot of noise. I don't know if all the other are having the same, but it means the concept you are presenting is new, but based on old aviation experience. And so you are the demonstration that is probably true what I got often as a feedback from my staff, that is in the aviation, everything has already been invented in some way in the past. So, Frank, the floor is yours. Thank you.
Thank you very much, Sebastiano. We had some issues here with the connection, so if it's not good, I will just go back and retry. But I think you can hear me well. Thank you very much for the invitation also to speak in this panel. It is a great honor. And just the first slide, yeah, maybe the next slide. Yes. So what has already been demonstrated actually as a working principle in the 1920s of the last century, the airships and the zeppelins, it's coming back. Our organization, IMIU, which is a non-profit based in Boston, Amsterdam, made an analysis in 2015, and we saw that a significant amount of initiatives were taken. Two of them are here today, which will present after me. So that is Daniel Doulton and Sebastian Bougon of Flying Whales. Most important message, I think, of this development is that it's really a low carbon way, also low noise aviation, also with a very low and small environmental footprint. So actually, it's something that probably can be developed in, let's say, 5 or 6 years from now, and will actually be able to set off some of the emissions that are currently being emitted by cargo transport, and also, for example, for surveillance and cargo transport with helicopters. So here you can see some of the carriers that are being developed in my slide. There is even one that uses hydrogen as a lift gas, and I think that's also an opportunity for this sector to make opportunity of the development and the great wave of hydrogen uses in aviation. Some of the initiatives are using hydrogen lift gas. Those are really unmanned. But some of them also are using hydrogen maybe as a propulsion at a later stage, but also for energy storage. On to the next slide. I hope I'm still audible.
Yeah, we lost apparently Frank. I will suggest that we go on with, I don't know if Frank is back, but I suggest we go on with the two concepts of the new Zeppelin. And I will give the floor now to Sébastien Bougon, that is the CEO of Flying Whales. Sébastien, what your project is for?
Can you hear me, Sebastiano?
Yes, yes. And your presentation is on.
Okay, thank you very much. I cannot see it, but I trust you. Okay, thank you very much, Sebastiano. Well, actually, yeah, just to tell you a few words about Flying Whales, it's quite different from what has been discussed these days. We're not here actually to compete the planes. Planes are so much efficient for passengers and for very long distances. We're not here either to compete the helicopters, which have been developed for maximum speed, maximum flexibility, and also mainly for passengers. They can do some cargo, but very limited payload. And we found out here in France that we had a specific need for large capacity, talking about actually 60 tons, for point-to-point, means being able to go, let's say, about everywhere to pick up some load or deliver it from anywhere. So it's a very specific niche, which happens to be for us every day bigger and bigger, which generated these needs. So I don't know if you see the slide, but maybe we can launch it. And there is a short movie, about 2 minutes. So as I have 5, you could launch it. There is a short movie of 2 minutes that will show you how actually it is going to operate. Can you launch the video, please? Still not. Okay. So I'll do it without video or pictures. The idea here is that our very first application is for wood extractions. It's a key issue we have in France. And for that, we had to develop a solution that could not land to load and unload. And this is the key point, actually, in this next 3 minutes. If you only have one thing to keep in mind, is that our customer forces to develop something that is loading and downloading from stationary flight up to 60 tons. And this provides us with two revolutions. Number one, point-to-point 60 tons without landing offers so many potential applications for wind blades, special convoys, unlocking what we call landlocked areas like highlands in Indonesia, the great north of Canada, and so on and so on. The second revolution it provides is actually for sustainability. As we load and download from stationary flight, we have no footprint at all at the ground. You see, we don't need any roads or any infrastructure to operate. And moreover, as the airship actually floats, the energy it needs is something like 30 to 40 times less than a plane or a helicopter for the same payload capacity per tons, let's say. So as we need much less energy, we go straight, exactly like Jean Botti, but for cargo transportation, we go straight to hybrid propulsion, okay? Because to be honest, it's much easier than for large planes or even helicopter. I mean, we're floating. Of course, we have to be certified, but we have more room, we have more weight capacity, so we can go straight to this technology. And what is interesting with this is that very quickly we will be able to substitute the turbines with hydrogen fuel cells as soon as this technology will be ready to be certified, which means that in this case, our hybrid chain is going to be a full 100% electrical chain. And then you can see we have a solution without any impact on the ground and without any impact in flight when we operate. So this leads us to develop a cargo transportation, large capacity cargo transportation without environmental footprint. Of course, we have to build it. Of course, we have to store it in bases, but in operation, we will hardly have any environmental footprint. Okay, I don't know if it's clear, but you have the big picture without any presentation.
So it means the person that were connected to this session had the possibility of following you presenting your project and also seeing the movie. So it was positive for this. Thank you very much.
Hope you enjoyed it.
I will ask a similar question as to the other. Means your project it looks quite advanced. We already discussed this in the past, and I saw that you have also make good connection with countries that they are interested in. You mentioned Canada, but I know that you are also involved with China, etc. So, Sébastien. When do you believe that you can enter into business with this extremely interesting opportunity for cargo?
Well, actually, we already are talking business with many different end users, as we used to say. As you may see on the slides, maybe, is that we actually are developing two companies, Flying Wheels Industry. Let's call it with a lot of modesty, in particular in front of Jean Botti, let's call it the Airbus of the large capacity airship, but also the Air France of large capacity airship, which is Flying Wheel Services. So Flying Wheel Services is being developed, the operator, and is already talking with wind blade manufacturer, with a large operator for high voltage pylons, of course, ONF, our French customer. So we already start to build the business case with them and prepare the operation. So the good question is, when are we going to be ready? And as you all say, aerospace program are something like 8 to 10 years long. So we started engineering in 2017. We are about halfway. Our CDR should be passed in, let's say it again, 2 years, by the end of 2022. No, actually 1 year. 2 years, sorry. Then we will build the first aircraft in the region Nouvelle-Aquitaine, the first large capacity airship in 2023. Then we have 1 year and a half of ground test and flight test in order to be certified. We are already applicant actually at the EASA since 2018. And then the real operation should happen in 2025. So it still is a long road.
Yeah, but you are quite advanced. All the best for your project. Let's see now. Let's see now with Daniel Doulton another possible use of these different technologies, different kind of aircraft. So Daniel Doulton is a project manager and business developer of Sceye. Can you kindly present your idea, Daniel?
Yes, hello. Thank you for welcoming me here. Firstly, I hope you can hear me. I'm having problems with my audio this end.
I can hear you.
Can you hear me?
I'm back again.
Okay, great. Let's proceed with this. Firstly, my name is Daniel Doulton. I'm from Sceye, and we are involved in the development of stratospheric platforms. Specifically, we have developed an airship, as you can see in this slide. The hero of the story is sitting in our hangar in Roswell, New Mexico. We have applied material science to solving the problem of endurance in the stratosphere, which is a very harsh but very stable place from which to operate. And the shiny materials there aren't just a product of us wanting to look good, but really a product of us wanting to create materials that are reflective and very capable of long endurance. We are a helium lift, natural lift-based platform, and our objective is really to change the way we think about deploying technology, particularly infrastructure. Our story really is about lifting infrastructure into the sky. And when you have an airship that is capable of lifting hundreds of kilograms and powering tens of kilowatts of power, you have many options for what you can do. So as a stratospheric platform stationed at about 65,000 feet, or roughly 20 kilometers up, we have a unique vantage point to distribute our technology in the sense that we can source data and connect people. And our vision and our mission is very much around impact. So starting with people, one of the applications that we aim to solve is the problem of broadband connectivity. Whether that's direct to your mobile phone, which we can achieve from these altitudes, or whether it's providing broadband to your home, to your office, to a hospital, to a school, wherever you need. And from there, as you can see, we have a very wide range of service, some 70,000 square kilometers of coverage from that altitude. The second area where we are aiming to provide great impact is for our planet in a new capability in remote sensing. In fact, at this altitude, we're close enough to see things in very high detail. And because we can sit still, again, we're able to observe things over extended periods and provide very high resolution information as data so that we can help people who are tackling the complex issues of atmospheric, climate change, ocean, and land sciences themselves. And finally, the other area where we're seeing great pull-through and application is in the aspects of protection and prevention. Because we can see and survey and provide a very wide domain of awareness, we're able to provide detection capabilities way in advance of what's possible today, either between satellites or low-altitude craft. So we can detect and hopefully detect even the precursors to events, natural disasters, whether they're fires, forest fires, floods, storms. If you apply this in the maritime areas, we can certainly spot specific vessels, their movements, their type, and classify them so that we can protect from illicit activities such as those undertaken by dark vessels, where you find people fishing illicitly or dumping or dredging or doing things that they don't want to be seen to be undertaken. And finally, in terms of search and rescue, extensive studies we've undertaken show that with our capability, we can effectively remove search out of search and rescue. Next slide, please. Let's take it out the hangar. So this was a flight that happened just 2 weeks gone. That was our 6th test flight and successfully flew from our hangar in Roswell from the previous slides. Next slide, please. So in the applications of broadband, it is a massive world challenge. There are some 3.6 billion people who are connected. To bring it home, as a good example, where I currently live in the United States, some 40% of the US doesn't have broadband connectivity. So in our own backyard, we have a major problem, and one which can really only be solved by a non-terrestrial approach, so that we can distribute signal to every square kilometer of this continent. Next slide, please. And briefly, how do we do it? The concept is very simple. We are very large, and we can carry very large panels, very large arrays, active microarrays. And the beauty of that is that we can now place signal and connectivity exactly where it's needed, whether it's the farthest corners in remote, difficult to reach areas where there's no power, but there are people or there are needs, or whether it's for moving craft, or whether it's in urban areas where additional capacity is required. And the benefit is that unlike terrestrial solutions, not only are we green, but in fact our economics get better with coverage. Terrestrial economics get worse. And what this really means is that we can finally provide what we call public equity in access to the internet. This shouldn't be determined by where you live. This is a basic human right, much as water, power, and electricity are. Next slide, please. And lastly, just to give a quick piece of color to our capabilities, we've been working, in fact, with leading climate organizations, and in fact, undertaking a study with the European Space Agency, HAPS-VIEW, in which we are demonstrating the capability to monitor and provide real-time climate and pollution monitoring over wide areas. And one of the benefits of this is that, in fact, because we can persist, we consider a stationary point, we're able to provide what's called characterization information and allow true measurements of activity in terms of pollutions, rates, directions, and whether that's an unnormal, as in abnormal or normal. Next slide, please. And similarly, in fact, we've also undertaken another study with, in this case, again, the European Space Agency for wide area monitoring, both maritime and inland. And one of the capabilities carrying cameras, hyperspectral, infrared, is that we can see a very rich tapestry of what's really going on. And again, could we spot natural disasters such as fires before they occur? It's very likely there are preconditions now that are well understood, and we can look for a combination of things like temperature, moisture, chemistry in a certain area to start providing a forward warning capability. Final slide, please. And finally, this is what it looks like from inside our airships. It's actually one of the gas cells themselves. So we're well on our way. We are in our demonstrator phase at this point. We expect to complete that in the next 18 to 24 months, and much look forward to bringing stratospheric airships from Sceye into commercial service. Thank you.
Thank you very much. Quite interesting, and it's also quite advanced, and the opportunity that they can come from your operation.
Someone relate your question to me.
Can you hear me? The others can hear me? Yeah. Okay. So we are and Shanna.
What was your question, Sebastiano? Can someone relay your question to me, please?
Yeah, the question was, what do you still have to solve in order to respect your timetable?
I'm sorry, I can't hear you, Sebastiano. Can someone relay the message or his question to me so I can answer for you?
Okay, we will come back to you later on. For the time being, let's end up this section with Frank Neumann, that was succeeding in reconnecting with us. Do you still have a few minutes for ending your presentation, Frank? The floor is yours.
I hope you can hear me.
Yes.
Okay, good. My presentation is not showing, so I think that If it's not possible to show my presentation, I think in that case, just here I see it very well actually. How much minutes do I have? All right. So I think that maybe it's already underlining what Daniel said, as well as Sébastien, is that the development of these demonstrators is underway, and not only from Flying Wheels and from Sceye, but there are worldwide probably 10 or 12 serious contenders like this, and IMIU and some of these partners established the international platform to bring this technology to the next scale, because we think it can offer a lot also in terms of replacing more carbon-based aviation activities by low carbon with a low environmental footprint, also following up on the UN goals of sustainable development. Maybe next slide. Maybe I should do it myself. The next, yeah. But of course, there's always a but here. There are quite big challenges, even although this technology was quite proven already a century ago. It was with very different materials, of course. There were no plastics, there was no systems for autopilot or good weather predictions. So now there are a lot of opportunities, but basically we see that it needs to be found out again how this actually worked. And probably the biggest challenge is that there should be also a different kind of ground infrastructure than from conventional aviation. So a lot of funding is necessary. And one of the problems is at this moment, actually there is not light and air included in most of the European financing programs. Of course, there are possibilities for introducing innovations in aviation, but light and air is not mentioned as a separate item, and a lot of technology development is still necessary, also with respect to the infrastructure. So with this platform, we try to attract public and private investors. It was also mentioned by Michel, which is necessary to accelerate innovation in aviation. And that is an ongoing process. Some of governmental agencies and countries already invested in this technology, notably Canada, France, and China. So yeah, that is one of the biggest challenges, because quite a lot of funding, additional funding is needed at the moment. Second point, the technological challenges I already mentioned. There are new materials, so it can be a lot more efficient than a century ago, this technology. But some of the aspects still needs to be tackled. Also, the new marketing of hydrogen, for example, for propulsion, or as a lift gas, or storage, or for use in the air. That's something which we hope this sector can also make use of the current energy in hydrogen applications. And furthermore, of course, certification needs to be developed for takeoff and landing, as well as some of the other technologies. And then maybe we already go to the final point of the common challenges. And one of the other aspects, which is very important, and maybe also is also an opportunity for some of part of the aviation sector, which is now suffering, is that this sector also will need not only researchers, but also a lot of other commanding staff and operating staff. So one of the challenges also will be to develop a stable and a growing staff and personnel basis for this sector. So that will be also one of the aspects of a joint cooperation. Then I will go to the next slide. I'll be finishing in 1 or 2 minutes. So here you see a quick overview of some of the main partners, which include renowned academic institutions, as well as developers. Some of the developers you've listened to today, and actually this afternoon there will be a side event also, which will also shed light on some of the other initiatives. And of course, we're very happy to have also the cooperation of DG RTD, of the European Commission, as well as EASA, who is participating in most of the key meetings. Next slide, I think that's the final slide. So next steps are indeed the further development of this financing aspect. And then the next one is that we are also planning a number of open meetings. So one meeting will be planned next year during Sustainable Energy Week. where also we hope to showcase some of the progress of the different initiatives, and maybe the next slide. And then also, hopefully, because of improvements in COVID next year, we also hope to have an actual site visit where people can actually see workshop, the hangars where these carriers are being developed. So then, yeah, I come to the last slide, actually. If you want to have more information about the various developments, please write us. Soon there will be another website in the air, but for the time, you can use the website which is shown here. Thank you very much.
Thank you very much, Frank, for having completed your presentation. And of course, it means this goes very much in line with the presentation of the two different typology of future Zeppelin or lighter than air technologies that they are very, very close to become operational. Before going to the last session of questions, I would like to give the floor to Andreas Hardeman, that is the head of the European office of the Boom Supersonic. Person who knows me know that I am particularly excited by a new era of supersonic aviation. Your project between all the one in supersonic seems to be the most advantage. My question is simple. When I can buy a ticket for one of your aircraft?
Okay, I hope you can hear me.
Yes.
I will try to answer your question a bit later, perhaps, as to when we can expect to buy tickets. Thank you, first of all, Sebastiano, for the introduction, and to the European Commission for the invitation. We're very excited to be part of this panel. Boom's vision of future aviation is a supersonic future, obviously, where we see speed, safety, and sustainability go hand in hand. Last month, we rolled out our XB-1 demonstrator aircraft, which will now undergo extensive ground and flight testing in the coming year. And in parallel, we will then also start building Overture, which is the first supersonic commercial passenger aircraft since Concorde, and that will have a planned rollout date in 2025. Of course, we are very conscious of the need to minimize future noise and carbon emissions, which is why from day one, we are designing Overture in a way that will meet and exceed applicable environmental standards. It will generate no net new noise, and it will be able to fly safely and economically on 100% sustainable aviation fuels. With that, allow me to share with you a short video, which is the cue for the people in the régie to line that up, which will give you the opportunity to hear directly from our founder, Michel,
without
and some of my
compromise,
colleagues.
where we can achieve speed, safety, and sustainability. Those are the principles that guide us. But speed is at the core of what we are building. When London is just 3.5 hours from New York, you can cross the Atlantic, do business, and be home in time to tuck kids into bed. When Sydney is 8 hours from Los Angeles, Australia becomes as accessible as Hawaii is today. And when Montreal is 4 hours from Paris, no relationship need be considered long distance anymore. Speed allows us to do more, to see more, and no destination will be out of our reach. Now I'd like to hand it back to Brian to talk about how we're building safety into Overture from the ground up.
Speed is what motivates us, but safety is always at the forefront of our minds here at Boom. It is part of our DNA and influences every decision that we make, from engineering design and employee wellness to the health and well-being of our future passengers. As you know, regulation and certification can drive a tremendous amount of requirements to airliners, but those are minimums. Our objective is to exceed those expectations and provide additional features not readily available on other aircraft. We are thinking of ways to make flying on Overture a restorative experience, allowing our passengers to arrive refreshed and energized.
Thanks, Brian. Well, that brings us to sustainability. At Boom, we believe that travel is a fundamental human good, and a planet in which we can go more places more often is a better place to live. However, we don't want you to have to worry about the adverse effects of travel on the planet. And so we challenged ourselves to make Overture 100% carbon neutral from day one. The good news is there's a new generation of jet fuels, fuels made from carbon that was removed from the atmosphere. And we're designing Overture to be the first airliner built from the ground up to run on 100% sustainable alternative fuels. To tell you more about how sustainability is built into everything we do at Boom, I'd like to invite up our sustainability team and some of our key partners.
At Boom, we're taking an all-encompassing approach to vehicle design. This is everything from how we develop and test our aircraft, to how we design our production facility, to what we're doing for the end of life of Overture, the recycling process, and also making sure that we're setting our airline customers up for success in terms of minimizing community noise impacts and ensuring that Overture is a zero carbon aircraft.
It's a company that's led by folks that have grown up in an environment that's very, very respectful of sustainability. So it's been refreshing to really see a company that embraces sustainability.
From day one, Boom has understood the opportunity that their products represent in demonstrating the viability of sustainability in air travel. They've incorporated the ideas and concepts of sustainability into the Overture program, and most recently, they have pledged that both the flight and ground testing of the XB-1 will be carbon neutral.
We've built relationships in the sustainable fuel supply chain, including with Prometheus Fuels.
Prometheus Fuels removes CO2 from the air, so that when you use these fuels, they don't add any CO2 to the atmosphere, they don't contribute to global warming, truly renewable fuels. And our goal is to make the future of supersonic flight carbon neutral.
The renewable energy is there, and we now have a path via which we can use sustainable alternative fuels.
So at Boom, we are building the world's fastest airliner, and there are unquestionable benefits to speed for society. But we don't think speed has to conflict with sustainability. These two things can be compatible. We enjoy the benefits of speed, but we're also making sure to be good stewards of the planet at the same time.
Back over to you, Sebastiano.
Thank you very much. Your film, your presentation has answered one of the questions that probably most of the people that are looking at this panel will have to do with supersonic aviation and environmental goals. They seem to be apparently not reconcilable concept. But if you are going in the direction you were presenting, means at this point maybe something that should be reformulated in the future. So thank you very much for your presentation. You still have to answer to my question, means when I can buy a ticket, but at least
I'll let you know offline.
Okay, and if you need someone for making the first fly, I am at your disposal. So it has been a very interesting journey. I think we have seen a lot of different aspects of a potential different way of using the sky for business, for transportation, and before giving the floor to the questions and answer that they can come from the audience, I would like just to ask all the different panelists if they have some reaction on the others' presentation. Means if there is something that you would like to ask to the other panelists, this is now your opportunity.
Sebastiano, can I ask a question?
Yes, of course. Sorry, Joris.
Yes, I'm very particularly interested in the supersonic flight, because that's maybe the holy grail in aviation to achieve. And you worked on sustainability at Boom. You looked at climate or CO2 neutrality, carbon neutrality. But how about the non-CO2 effects? how are we going to tackle that one? Because that's CO2 neutral is probably not going to be enough anymore in the future.
Excellent question, of course, Joris. I hadn't expected anything else. Indeed, as you say, CO2 is only part of the story. Actually, we saw the EASA report. I think that came out yesterday, which was developed in conjunction with CE Delft, not TU Delft, but CE Delft. And they actually take a very hard look at sort of the non-CO2 emissions, including NOx emissions, which we know affect local air quality, but also climate change through ozone formation in the troposphere, and has the potential to affect sort of the stratospheric ozone column as well. So there's plenty of good reasons to keep NOx emissions under control and as low as possible. And that is why we're working with our engine partner Rolls-Royce already to design specifically a low NOx combustor and engine for Overture. So we're in the meantime very much welcoming the continuing research in this area, because it does inform our design process. Of course, in addition to NOx, there's also the issue mentioned of contrails, enhanced cloudiness, and how to mitigate those. But I think we have reason to believe that contrail formation will essentially remain mostly an issue at tropospheric cruise altitudes where subsonic aircraft tend to operate, rather than the stratospheric altitudes where supersonics will be flying, because the stratospheric atmosphere, as you know, is quite a dry environment to operate in. So the generation and creation of contrails will be probably less of an issue. And I think the only outstanding issue that we still need to have more research in is that of water vapor. So that is definitely something we. Sorry, I'm hearing my own echo. It's a bit disturbing. So yes, water vapor, I think, is something that we will continue to look into in years to come. Sorry.
Andreas, I'm sorry. It's true that we have this echo, but there are a couple of questions related to supersonic from the audience. One is related to noise. Means they are saying that the former supersonic programs were killed also partially to the problem of noise. What is the solution you are looking at for avoiding the problem of the boom?
Well, I think so. Looking at or talking about noise issues, we separate or we look separately at the issue of community noise, which is really related to takeoff noise. And we all know that Concorde was extremely noisy on takeoff, mostly due to the use of afterburners. Overture is designed in a way that afterburners will not be used. So in that context, we expect clearly to be departure noise be lowered substantially. There's also operational measures that can be used, reduced thrust takeoff settings, for example, through the use of something called programmed lat rate, which is a sort of computer-managed automated thrust reduction immediately after takeoff roll. And also because we are targeting the latest international subsonic noise regulations under ICAO Chapter 14, we are confident that on takeoff and also landing, Overture will be quieter, in fact, than many of today's large commercial airplanes. Now, in terms of sonic boom, because I think that the question specifically mentioned sonic boom, again, at an international level in ICAO, governments are currently evaluating standards for overland sonic boom, which I believe is the correct long-term strategy. But I should highlight probably that Overture will only be cruising at supersonic speeds over water, which means that there is no sonic boom that will reach areas where people are concentrated, live and work. We also, for example, incorporate what's called coastal buffer zones into our planning, into our route planning, and the sort of modeling assumptions that go with that. So again, to ensure that sort of Overture will only be cruising above Mach 1 once it reaches an acceptable distance from the shore. And I think looking ahead a bit further, I think once we've been flying supersonic over water successfully, and we see flight technology continuing to advance, I think ultimately it might become appropriate to discuss some regulatory changes to allow supersonic operations over land, but that we're really looking at sort of a second generation Overture. So eventually, I think we'll move from an overland speed limit, which exists right now in many places, to an overland noise limit for sonic boom, and we fully intend sort of future generations of Overture to meet those limits.
Thank you very much. Thank you very much. And now there is another question from the audience, and they are true. We are missing what's happening in the space sector in this panel. And maybe I can ask Joris to provide some a reply to this. Means there are also other way of thinking about transportation from, for example, Los Angeles to Tokyo by using these hypersonic or whatever new aircraft. Can you reply to the audience question, please?
Of course, that's also very nice to think of. You could do a suborbital flight. Technically, that probably would be possible. We also shoot humans into space. Look at Elon Musk. If you would do a suborbital flight, you could go even faster through Australia than supersonic flight. Practical execution is probably going to be the issue, also a sustainability issue. And one of the most critical things there probably would be re-entry, because you exit the atmosphere of the Earth and you also need to get back into the atmosphere, and re-entry is always a tricky thing. So yeah, it's not impossible, but again, I don't think this will be transport for the masses.
Thank you, Joris. So something that is less close than what has been presented today in this panel. I have a further question this time to Michel. You were calling upon the Commission to review Flight Path 2050. And this is something that we will certainly do. But you were also advocating for a comprehensive strategy for technology infrastructure in Europe. That is another element that is extremely important. So what shall we do?
Okay, you're quite right. In order to achieve innovation in all of the targets, what we want to achieve, climate neutrality and you name it, you need a lot of knowledge in the heads and the minds of the people, of the engineers, being the university, applied research, industry, etc. But you also need research infrastructures, and that's a little bit the raison d'etre also of applied research organizations on EREA. They have validated research infrastructures in order to validate those new technical concepts, ranging from wind tunnels, advanced wind tunnels, normal atmospheric wind tunnels, cryogenic tunnels, to and including flight sim research flight test aircraft, in order all to test and to take the technical risk away before an aircraft or parts or whatever can be mass produced. The Commission is putting, if you look at the history, is putting a lot of money into research infrastructures. But they are, well, between quotes, fundamental, like CERN and that kind of stuff. Very good. We are making a plea to extend between quotes, of course, also to applied research infrastructures, because they are as essential as fundamental research infrastructure. So we are more than happy to work with the Commission in order to make that plea, and I have good hopes that we will find well, that's a direct Dutch translation, a willing ear at the Commission that they would understand this, but also the vitality. If you really want to get the technical risk away of all those new concepts, which are mostly mandated basically by the Green Deal, zero emission, and that's nothing. You have to really do a lot. Then you have to validate that in an operational environment as close as possible. And basically then we are talking about research infrastructures. They are very important.
Yeah, and we can. I totally agree with you, and we can build on the achievement that has been done with the European project that we have financed last year. That it was the Ringo on research infrastructure. So we have a good basis for reflecting for the future. So we still have 6.5 minutes, more or less. I would like to ask all the panelists to give a final message, 30 seconds each, starting from Joris. 30 seconds.
Thank you very much, Sebastiano. I'll take my 30 seconds again by just calling up and make our dreams may come true. We must dream bigger. We take 2 small steps, and of course, for safety reasons, we must take small steps. We cannot make a kaboom supersonic aircraft if we don't know whether it's safe or not. But we must dream bigger. And normally what you see is that we have long-term visions, long-term dreams, but we don't make them true. So we need to invest in people, we need to invest in research infrastructure, we need to invest in research and development much more, and then we can make our large dreams come true.
Thank you. Especially investing in people, that is very important. Michel, 30 seconds. We cannot hear you. You're muted.
Is this better?
Yes.
Okay, good. Thank you. I was going to say I don't need 30 seconds, but with this interruption I do. I dream of completely emission-free, not only emission-free aircraft, but an emission-free transport system, which is more than alone the aircraft. Also end-of-life solutions, that when a aircraft is decommissioned, then it gets back into the system. And with all the combined knowledge we have within Europe, all the players which are around the table here, with the startups, with the big OEMs, then that certainly is possible.
Thank you. Now it's the turn of Jean. Jean.
Yeah, for me, we need to remove the aviation from the environmental equation, okay? And we heard lots of things, hydrogen, lots of ideas that are really good, but we have to live, in the reality, and the reality of I would say, the technologies as they are. This is what we're trying to do at VoltAero, revolution by evolution, and take it step by step, and we need to start now. If we want to make sure that in 30 years we have, or in 20 years, a full hydrogen airplane, yes, but it needs to start with the technologies of today and take it step by step. So we need to develop the technology bricks, and in Europe we have everything that is needed to be able to do so.
It's good. We need to start very quickly to do things. So now is Frank, 30 seconds.
Much. Very short, perhaps. We see that the past aviation has particularly also been the domain of very large companies for development. I hope that in the coming years, also considering the environmental challenge, there will be more cooperation and openness on all sides, also from smaller companies that are developing innovations. I think cooperation is the only way to make this bigger change towards a lower environmental footprint aviation possible.
cooperation is a word that we use a lot and is the key. Let's move to Sébastien. You still there? No, we lost Sébastien, so I will give the floor now to Daniel. You are still with us?
Thank you. I'm still
Daniel?
here.
Yeah, we cannot hear you. Maybe unmute yourself.
I'm unmuted. Can you hear me now? Can you hear me now?
Yes.
Excellent. Thank you. So look, I think from our perspective, the stratosphere is a layer that has long been of interest to space agencies. And it's interesting, we're at a stage now where technically it is feasible for us to open up the stratosphere and really leverage the technology sitting under our noses. We have the technologies. We need the will now to support us to exploit this layer. And the reason I champion it is because we can do things that are far more capable either from space or from layers below. We are completely green, solar powered, natural lift. And the impact we can have in a very short time on our planet, on our people, etc., is right in front of us. So we'd much welcome strategic support, not just at the industry level, but at the national level for this and regional level. So yes, go stratosphere.
Thank you very much. Andreas, 30 seconds.
Yes, go stratosphere, certainly. I think I would want to sort of just say a few words about the current situation that our industry is in. Of course, the whole pandemic has plunged the sector into a crisis we've never seen before. Short-term predictions remain unknown. I think long-term, though, our sector is driven very much by fundamentals. So personally, I'm convinced aviation will get back up again. And many things will go back to how they were before, but at the same time, I think we are seeing some very exciting changes. We know external shocks tend to spark innovation, accelerate change, and just listening to some of the presentations today, I think proves that point. The other point perhaps is that sort of on current expectations, something like 75% of aviation CO2 in 2050 will still come from long-haul flights, where currently it doesn't seem that electric or hydrogen propulsion will be feasible. So we do need to look at that mix of solutions, bring sustainable fuels very much into the equation to make sure that sort of in the future those long-haul flights will have the potential to become carbon neutral as much as the short and the medium haul.
Thank you very much, Andreas. With this, this panel come to an end. I have to say that I'm satisfied. I would like to thank once again all the the panelists, especially the ones that they are connected from the USA. Thank you very much. Happy Thanksgiving to you. I think that this panel has been, despite the technological problem, connection, etc., a nice way of concluding the Aero Days Forum. I am looking forward to see all of you for the closing remarks. Thank you very much. Enjoy. Bye-bye.
Thank you very much, Sebastiano, Fumero, and thank you so much, distinguished panelists. This really has been a journey into the future of aviation in spite of these digital turbulences in between. So again, thanks to you. So folks, we are on the finishing line of our Congress, but we want to embrace all the things we heard the last days in the short, high potential closing session. So please stay tuned. Our closing session will start in 10 minutes at 2:10.